Good morning, students. I am Nilanjan Das Chakladar, Assistant Professor of Manufacturing Science and Engineering, Mechanical Engineering Department, IIT Kharagpur. Today we are going to learn Module 3, Lecture 11 on Manufacturing of CMCs, LPI, Liquid Phase Infiltration, and LSI, Liquid Silicon Infiltration processes. Coming to liquid phase infiltration process. So in the LPI method, liquid matrix is infiltrated into long continuous fibers through one of the following processes. Infiltration of molten ceramic. The molten ceramic is infiltrated in a fiber preform and is limited by low viscosity of molten ceramic and by high temperature, causing a chemical interaction between the molten matrix and the dispersed phase fibers. This process is sometimes used for fabrication of glass matrix composites. Now try to remember, when you have studied infiltration methods for ceramic matrix composites, so the infiltration method is essentially guided by the capillary process. So the same thing we are seeing in liquid phase infiltration as well. What about in slurry infiltration process? It involves passing fibers or tow through a slurry containing particles of the ceramic matrix. That means the slurry is made of particles which are nothing but the ceramic matrix. Then winding the fibers impregnated by the slurry onto a drum and drying it. So the stack of the slurry impregnated fibers in a desired shape and then consolidates by hot pressing in a graphite die at high temperature. So these particles, they have to change in shape based on the die used. So they cannot stay at their position. So the particle has to be uniformly converted into a dispersed matrix, and that is assisted by the hot pressing in a graphite die. Now, reactive melt infiltration. What is it? RMI is primarily used to fabricate silicon carbide matrix composites. Now we have seen silicon carbide matrix composites can be manufactured using the chemical vapor infiltration process. It can be manufactured using the PIP process, that is polymer infiltration and pyrolysis. It can also be manufactured using reactive melt infiltration process. So the process involves infiltration of carbon containing preform with molten silicon. So infiltration is usually capillary driven. Carbon of the impregnated preform reacts with liquid silicon, forming silicon carbide. So that means the silicon carbide matrix is being formed in situ. Resulting matrix consists of silicon carbide and some residual silicon. Now whenever we say some residual silicon, that means the complete reaction has not taken place. Okay, so it may mean that we further have to re-infiltrate with carbon so that the remaining silicon is again converted into silicon carbide. Other examples of RMI: when liquid aluminium is used to infiltrate a preform in oxidizing atmosphere, aluminium matrix is formed. Okay, so liquid aluminium, this is an oxidizing atmosphere, immediately aluminium oxide is formed. This is called direct oxidation process. RMI is fast and relatively cost effective. Materials fabricated by RMI method possess low porosity and high thermal and electrical conductivity. So polymer infiltration and pyrolysis method, this we have already seen. It involves the following steps. Fiber preform is soaked with a soft polymer heated, forming polymeric precursor. So this PIP process is also a liquid phase infiltration process. The polymer is cured or cross-linked at 250 degrees Celsius. Polymer precursor is then pyrolyzed at 800 to 1300 degrees Celsius. As a result of the pyrolysis, the polymer converts into a ceramic. That means it is a polymer derived ceramic, or we can also call it a pre-ceramic polymer. Pyrolysis consists The pyrolysis causes shrinkage of the matrix material and the formation of pores up to 40% by volume. The pyrolyzed polymeric precursor may be hot pressed for densification. Hot pressing is limited by possible damage of the fibers. That means we cannot keep on hot pressing it. The pressure with which hot pressing is done is very important so that we do not break the fibers or damage the fibers. Infiltration pyrolysis cycle is repeated several times until the desired densification takes place or desired density is achieved. Examples: matrices containing carbon, silicon carbide, silicon oxycarbide, silicon nitride, silicon oxynitride may be fabricated by this process. So matrices used as polymer in case of PIP method can be thermoset. They can be pitches when your objective is to make a carbon matrix, polycarbosilane, polysylestyrol, dodeca-methyl cyclohexacillane for fabrication of silicon carbide matrix. PIP methods are simple, low temperature methods which allow production of complex intrinsic parts. Now coming to liquid silicon infiltration. So as the name suggests, it is the liquid silicon that is going to be infiltrated. So let's see how it is done. Liquid silicon infiltration process is a type of RMI technique, reactive melt infiltration technique, in which the ceramic matrix forms as a result of chemical interaction between the liquid metal infiltrated into a porous preform and the melt. So see, all the infiltration methods, it has a porous preform, it has a melt, there is capillary action. Since the material is different, you get different names for the infiltration process. LSI is used for fabrication of silicon carbide matrix composites. Obviously, it is understood silicon is there. Silicon carbide matrix, it can be a classical example, or silicon nitride matrix. The process involves infiltration of carbon microporous preform with molten silicon at a temperature exceeding its melting point of 1414 degrees Celsius. The molten silicon wets the surface of the carbon preform, wets, so we are interested with the wetting or the contact angle. The melt soaks into the porous structure driven by the capillary forces. The melt reacts with carbon forming silicon carbide. So you have liquid silicon, you have solid carbon, and then solid silicon carbide. Now silicon carbide produced in the reaction fills the preformed pores and forms the ceramic matrix. Again, you will find as we keep on reducing the pores, we increase the density, we get a better quality ceramic matrix. The initial pore volume fraction providing complete conversion of carbon into silicon carbide is 56.2%. That is very high. So if this value is less than 0.562, the infiltration results in entrapping residual free silicon. Commonly, at least 5% residual free silicon is left in the silicon carbide matrix. The porous preform may be fabricated by either pyrolysis of a polymerized resin or by chemical vapor infiltration. We have already studied what is chemical vapor infiltration. The preform microstructure is important for complete infiltration. Large pores, they help to obtain a complete infiltration but may result in incomplete chemical interaction and formulation of a structure with high residual free silicon and unreacted carbon. What does it mean? It means if the pore size is higher, is larger, then although there is complete infiltration, the chemical reaction between silicon and carbon has not taken place. So the size of the pores is equally important. For small pores results in more complete chemical reaction, but in incomplete infiltration due to blockade or choke off of the infiltration channels. So this is exactly what we studied in case of chemical vapor infiltration. If there are surface pores and those small surface pores, if they are quickly blocked or choked, then the pores which are at the bulk, they remain porous. So still the density, we cannot say it's a high density, it's a good quality silicon carbide or ceramic matrix. ceramic matrix composite. So we have to be very careful about the size of the pores, the repeated cycles that are being carried out, the pyrolysis and infiltration cycles, such that the densification is as per our requirement. In contrast to the composites fabricated by polymer infiltration and pyrolysis and CVI, chemical vapor infiltration methods, ceramic matrices formed by LSI, liquid silicon infiltration method, are fully dense, have zero or minimum residual porosity. The infiltrated molten silicon at high temperature is chemically active, so it quickly converts the carbon into, reacts with carbon to make silicon carbide, and may not only react with carbon porous preform but also attack the reinforcing phase. Okay, silicon carbide or carbon fibers, whiskers or particles. Now sometimes it is good, sometimes it is not good. When it says it attacks, we do not want to destroy the structural integrity of the reinforcing phase. A protective barrier coating interface of silicon carbide prevents such damage. So we need to have an interface, not interface, interface. See, PHASE. How will we make this interface? Using the same method. So the barrier coatings or debonding coatings of pyrolytic carbon for carbon-based matrix and hexagonal boron nitride for nitride-based matrices are important. The interfaces may be deposited by the CVI process, and the protective barrier from pyrolytic carbon is formed by PIP process. Okay. Now coming to steps of LSI, liquid silicon infiltration, application of interfaces. This is the first step because we want better chemical bonding or chemical compatibility between the reinforcing phase and the dispersed phase and the matrix. Fabrication of the prepreg. Layup with the help of mold, or it is also called as tooling. Molding, pyrolysis, pyrolytic decomposition in an inert atmosphere with argon at a temperature of 800 or 1200 degrees Celsius. Primary machining is required after molding and pyrolysis. As I mentioned, some braiding operation is required at the surface so that you open up new pores, new channels, you repeat the pyrolysis, the infiltration cycle. Infiltration of the porous prepreg with liquid silicon, and final machining or grinding to desired shape and size. So what are the advantages and disadvantages? Advantages of liquid silicon infiltration: low cost, short production time, very low residual porosity, high thermal and electrical conductivity, complex and near net shapes are fabricated. Disadvantages: high temperature may damage the fibers, which is why we require an interface. Residual silicon is present in the carbon matrix. Lower mechanical properties of the resulting composite. Thank you.